Oh, good evening, everyone. Tony, thank you very much for that very generous introduction. As I said earlier on when I was talking to a women's group, the one thing about being one of the most inspirational women in the world is you need to look at the detail. My mum was very pleased with this because in Harper's and Queen, who published it, I came in at number 14, but she was particularly excited because I beat Camilla Parker Bowles, who came in at 39. But the thing should be tempered by the fact that number 9 was Dolly Parton. So we have to be careful there. It's a great pleasure to be back here. I have great memories, and it's very scary how that was a whole 6 years ago when I came. But I didn't come here, and congratulations on this spectacular place, and congratulations also on this initiative. As I was getting ready this evening, some of you have heard the Not Today programme, the 5 o'clock programme that goes out on Radio 4. And they were interviewing Lord Brown, and he was saying how really we ought to make much more of the technologies that are being developed in universities for commercialisation, and that there's fantastic stuff going on in universities here at the moment that are just falling through the cracks and could actually really be helping with wealth creation in these very dodgy financial times. So I think it's very appropriate and timely, and you ought to be congratulated on the fact that you bring these previously disparate sectors together. So what I want to do is stand before you, if you like, as a neuroscientist and lay out my stall as to areas I think that will be of issue, not just to you as business folk, but also as parents or just citizens of the 21st century, because I think this is something that engages us all, which is how the brain will work in the future. Now I'd like to start with the centre picture, because just to orientate us into what we'll be talking about, we are of course talking about the hero of our story here, which is the brain. I'll assume that most of you are non-specialists. Is that the case? You're not secret closet neurologists. I know I'm going to do this one day. I'll go to some talk and ask in a general way, this is a brain, and they'll all be neuroscientists or something. You know? So if you are a specialist, please bear with me. When I tell the story that if you are a specialist, you may have experienced yourself, which is when you first dissect a human brain. And I am aware that we're about to eat, but it's not for another hour. So, yeah. So the reason I like this picture of the brain in the hands is it reminds me of when I first did a human brain dissection in Oxford. As you heard, I started off life doing philosophy. I was an arts person, really. I came to science late. I changed to pharmacology and neurochemistry very late, so I wasn't used to dissection and so on. And they wheel in these trolleys with these Tupperware pots containing human brains. And you're wearing surgical gloves because the brain is submerged in formalin, a toxic chemical that enables you to keep it firm for dissection. But I remember thinking as I plunge, imagine doing this, yeah? You roll up your sleeve and you plunge your hand in, and then you hold in one hand, it only weighs about 3 pounds. You hold a brain in one hand. And I remember thinking as I was holding this, contemplating this smelly thing, boring looking thing, that looks like a walnut, if I wasn't wearing gloves and I got a bit under my fingernail, would that be the bit that somebody loved with? Would it be a memory? Would it be a hope? How can you have a hope under your fingernail? Huh? How can you? And yet that's all there is. You know, it occupies the same universe as nasal hair or earwax or tooth enamel. And yet, look what it does. And unless you've dozed off already, it's giving you an inner state that no one else can hack into, that we call consciousness, which I'll happily discuss in the Q&A, although that's not primarily our subject for this evening. It does fascinate me that this boring thing generates for you everything you hold dear, which is your inner state, your personalized view of the world, you as an individual, you the person, that makes you different from the person you're sitting next to. It's not your heart or your lungs or your liver. You could have those implanted in exchange with increasing frequency as technology advances. But brains, you might want someone to have a brain transplant, of course, but obviously it wouldn't happen. So what does the future hold for this very special part of you that is you? It is you. For the 100,000 years that human beings have stalked the planet, no one has a brain like yours. They might have hearts and lungs and livers like yours, but no one for the 100,000 years we've been around, not even identical twins, will have a brain like yours. That's what makes you unique, and we're going to see why. And how will it change in the future? Are we going to be, as top left, some kind of dysfunctional cyborg, some kind of robotic being devoid of emotion, devoid of everything we hold dear that we regard as part of our humanity? I always think that's how people think of scientists anyway, actually, like that, kind of grinning at some sort of world domination or something. Or, bottom right, this rather fanciful picture I picked up from the web of creativity and individuality and things that I'm sure many of you would put at premium. I'll tell you the conclusion now, actually, in case you want to. The conclusion will be the future is in our hands to be either of these things, and it's up to us as responsible citizens in the 21st century, whatever we do, whatever job we do, whatever specialism we have, to actually create an environment where we go in the direction that maximises human potential. Right, what I'm going to do then is start off by just laying before you your own brain, and just in case your mind wanders as you're thinking about the food and wine to come, my key points are numbered. So if you do find yourself wandering off, if the neighbour nudges you when a number comes up, you'll know that the conclusion is there. So here we are, the environment is key, right, and I can doze off. Let's look at this and explore what I mean by this, and my point will be that it is the environment that makes you so special. So let's think about that. Why are you different, let's say, from a goldfish? Now let's be brutal. Goldfish don't have great personalities, do they? I hope I don't offend anyone here, but if your kid had a goldfish and the goldfish sadly died, you could go off to the pet shop and buy another goldfish. Child would come home and they wouldn't know any different. Now, you couldn't do that with a pet cat or dog, or even a hamster. You certainly couldn't do it, even if they might want you to, with their brothers or sisters. Now, why is this? What makes us able to have individual personalities and not the goldfish? Why is it that you are unique? What it is about your brain and not the nervous system of other animals that will give you a varying range of the potential for individual? Well, the key lies into our particular talent as humans. We don't run particularly fast, we don't see particularly well, we're not particularly strong compared to many in the animal kingdom, and yet we occupy more ecological niches than any other species on the planet. And this is the clue to our individuality, because what we do more than any other species, they do it also, but we do it superlatively, and that is we learn. We adapt to the environment. And my key point I'd like to make first is this is where we start. The human brain is exquisitely evolved to adapt to any environment in which it is placed. And if you have individual experiences, then guess what? You're going to become an individual. So let's look at the basis for that. This is something that is called neuroplasticity. It doesn't mean to say that the brain is made of plastic, of course. It comes from the Greek plastikos, to be moulded. And here's a picture showing the human brain, newborn and 15 months. And forgive me if you're a neuroscientist, I'm going to use non-technical words. The blobby bits, neurons, are not really proliferating. The stringy bits, connections, are what is really characterizing the growth of the human brain postnatally. So even if you're a clone, an identical twin, you're going to have a unique pattern of connections. Why? Because these connections are formed after birth, and after birth you're having individual experiences, and these individual experiences are going to shape and mould and strengthen and endlessly update those connections. And I want to persuade you that this plasticity of the brain, these connections, is what makes you the unique individual that you are. So let's look at an example of that. Well, we're going to look at two examples. This is a very famous example that you may have heard of. It captured the attention of the media. I'm sure most of you are familiar with London cab drivers. I don't know about Belfast cab drivers, whether they have to do the same. Do they? No, they don't pass the knowledge, do they? No. Well, they'd be the good control group then, possibly. I don't know. But London cab drivers, much as one says many, many things about them, they do have to pass this very impressive test where they have to remember by heart how to navigate all the streets of London effectively and in the shortest possible time with respecting all the one-way systems. And then they have this ominous exam called the knowledge, an oral exam, where without recourse to a manual, they have to remember all the streets of London and take the examiner in their minds from A to B, just reciting off all the streets. So they have a huge burden on what's called working memory. And in this wonderful study that really justifiably, a while ago now, captured the attention of the media, Eleanor Maguire, a woman incidentally, and her colleagues scanned the brains of London taxi drivers. And what we're going to see now is what the result was for an area called the hippocampus. And I'm showing you this picture just because I think it's rather attractive. It's just rather nice, even if you don't understand about the brain, you can see how beautiful it is. Quite like this as wallpaper or something. It's, you can see the cells stained 1 in 10, and they're stained 1 in 10, so you can see in stark relief the shape of these cells with their beautiful branches lined up in a sort of serried rows. Now this area of the brain, the hippocampus, is an area that is well known to be related to memory. Many others in the brain are as well, but this is a particularly strong key area relating to memory. And when Maguire and her colleagues scanned the brains of London taxi drivers, she found that the area was bigger in London taxi drivers than in other people of the same age. A fact not lost on London taxi drivers. They've all heard of this study. If you take a London cab, Belfast cab, if you take a London one, ask them if they've heard of the hippocampus next time. And you'll say they've all heard. And it's not that having a big hippocampus predisposes you to being a London taxi driver, because the difference was more marked for the longer they've been driving. Why is this? Well, you're all familiar with the fact that when you exercise certain muscle groups, your muscles get stronger and larger, and if you don't exercise muscles, they tend to atrophy and get weaker, and you use it or you lose it. We're all familiar with this principle, which also holds with the brain. This is what happened with the taxi drivers. They were exercising, making active certain parts of their brain, in this case the hippocampus, and guess what? It showed up in the scanners bigger. Let's look at another example, which perhaps will strike, sorry, there's a terrible pun coming. I was going to strike a chord, which is awful, because it involves piano playing. I didn't mean it, but the words were out before I could push them back. So I do apologise for the terrible pun. But anyway, this experiment involved 3 groups of adult human volunteers, none of whom could play the piano. Now, if you get to volunteer for such an experiment, I agree, unlikely, a word of advice, try and not be in the control group, because they stared at a piano for 5 days, nothing else. However, there was another group, and these guys learnt 5-finger piano exercises. And again, we're going to look at brain scans over 5 days of the 2 groups, the controls who just stared at the piano, the people that were learning the piano for the first time, even over just 5 days. Forget a lifetime of cab driving, this is just over 5 days. But there's also a surprise group, and I'm going to keep them. Are there any philosophers here? Probably not, but I'd like to challenge, they never put their hands up if there are, they never, until question time, and they ask some very long, complex, technical question, only philosophers would know. Anyway, I'd like to challenge philosophers with this third group. So let's look at the 3 groups now. So going from left to right, you can see that's the 5 days of the experiment, and in the control group, as you can see, the brain is literally unimpressed. Nothing's happened to the scans over 5 days. But by contrast, look at the people that were playing the piano. Over 5 days, you can see there's an enlargement, clear enlargement of the functional territory relating to the digits of the people playing the piano. And that would fit with what we saw with the taxi drivers. You use it or you lose it, and you exercise something, you rehearse it, then you become more proficient, the area gets stronger. Look at the third group. These people merely imagined they were playing the piano. Now, we could talk about this slide all evening, I think, and you can see why I like to challenge philosophers with it. These people merely imagined they were playing the piano, and their scans have changed in a way similar to the people that were physically playing. So let's conclude 1 or 2 things from this. First is clearly the key factor here is not the contraction of the muscle, it's the thought that precedes it. And there's a wonderful quote that I've written here from a man called Horner-Kowitz, who developed the therapy for Parkinson's disease some 4 decades ago. Thinking is movement confined to the brain. And I want to come back to that. If I start talking about thinking again at the end, and I haven't mentioned the quote, can someone say, what about the quote to me? Because I think it's very important, as you'll see. I think it's a very profound comment. Thinking is movement confined to the brain, just illustrated beautifully there. You can also see we cannot draw silly distinctions, as in the past, between mental and physical, between mind and brain. Yes, I know it's hard, impossible at the moment, to relate these exotic mental events, these exotic emotions that we have, to the bump and grind of the squalor of the physical brain. But somehow it happens. And you can't have this dualist dichotomy of mind and brain, mental and physical, as you see. The one relates to the other in some way that we as yet need to understand. So what's the basis of that? Well, in order to try and find out what's going on at the nuts and bolts level, and that's what neuroscientists do, we have to turn to animals like rats, where you can actually dig into the brain. And rats, as you know, are very clever creatures, they learn and so on, so they're a perfectly appropriate model, they're not like goldfish to study. And what we use is a paradigm. Obviously you can't get rats to drive taxis or play the piano, so what you do is manipulate their environment and see how they interact with their environment and how that changes the brain. And as you can see here, a very popular paradigm, and this is one we use, is a so-called enriched environment. Now, enriched for a rat doesn't mean to say they come to the CEO club at Queen's and have a nice evening, hopefully, and network and stimulate their brains. For rats, being highly exploratory creatures, what they love, as you can see, is lots of novel objects and interaction with each other. And look how happy that rat looks down at the bottom. You can see, this is my own lab here, and you can see, so especially the one on the bottom right looks having a lovely time. They're really, compared to their counterparts in normal lab cages. Yeah? So I'm going to choose two brain cells from another similar experiment, not from our own particular ones, showing under similar conditions what happens to the brain cell, a single brain cell, from an animal in an isolated cage, ordinary cage, and one in this kind of enriched environment. Let's look and see. So again, forgive me if you're the specialist and I'm talking in non-specialist way, the blobby bit in the middle is the main part of the cell, and I'd like you to focus instead this time on the branches that are coming out. Compare those branches and the degree of branches with this brain cell, which was an animal from an enriched environment. And you don't have to be a card-carrying neuroscientist to see that in the animal, in the enriched environment, the branches are more extensive. Why, and why is it important and interesting? Well, why is because, as I said with muscle, when you exercise it a lot, it gets stronger and larger. If you make brain cells work hard, and that is what they are doing in an enriched environment, as opposed to just lolling around in an empty cage, if they are being made to work hard, then they're more active, and they will respond by growing their branches. Now, why is that interesting or important? Well, if you're growing more branches, you're increasing the surface area of the brain cell. That is to say, you're making more space for possible connections to come in from other brain cells, and up to 100,000 connections will converge on only one brain cell. There's lots of competition for space. So let's recap. A stimulating interactive environment makes brain cells work hard. They grow by making more extensive branches. Those extensive branches create more surface area, which enables them to have the potential to make more connections one with the other. Now, why is that important? Well, let's go back to us now. In the words of the great psychologist William James, we were born into a lovely phrase, a booming, buzzing confusion. And when you're young, you can't do anything else. You'll evaluate the world in purely sensory terms. How sweet, how fast, how cold, how bright. But gradually, as those early weeks turn into months, and the months into years eventually, if you have the same visual pattern that seems abstract at first, presenting again and again and again to you, then like with the taxi drivers, like with the piano players, connections will form unique to you and that pattern. And say that pattern, that erstwhile visual pattern, is accompanied by certain colours and sounds and smells, so you have a whole sensory experience. Slowly, that sensory experience will become what we call cognitive, from the Latin cogito, I think. It will start to have a significance. Let's say it will start to be your mum's face. And if mum, let's hope she does, features again and again and again in your life, more and more connections will form in a way that they won't in someone else's brain who just sees your mum for the first time. Your mum will have a significance to you that she does not have to others. Here's an example. Here's me with typical colleagues. Here are 6 white middle-aged men in suits and ties, as you would see them. But they are actually, David and Chris and Martin, they mean a lot to me because I've shared with them excitements of papers and grants being accepted, papers and grants failing. I know their hopes and their fears to a certain extent. I know their background. I know how many kids they've got. We have, when I look at that picture, which sadly now one of them has died, was taken a long time ago, it means a lot to me. I remember the day that photo was taken. It will mean nothing to you. It will just be a load of generic men to you. You could similarly show me equally emotionally driven pictures, and I will see them as generic men and women and children possibly, and that's it. So it's all due to the associations that you've previously formed that enables you to see the world in a unique way, to interpret it in a unique way. So you start off in this passive booming, buzzing confusion, but gradually, as associations form, so the one-way street becomes a two-way street. So now you'll evaluate what is coming in terms of what is there already. You will have the checks and balances of meaning and significance to you, but at the same time, the ongoing experience will upgrade the connection. So you're in a constant, ever-changing dynamic dialogue with the outside world. So I'd like to suggest to you that connections give an ever deeper meaning, a significance over time. These are brain cell connections. Let's take an example here of a ring, a wedding ring. If you show that to a small child, I imagine the child would be quite fascinated. You probably wouldn't give it to a baby, they'd swallow it. But let's say, forget the swallowing bit. A child would be fascinated by the shininess, possibly, by the fact you could roll it, by the fact you could put things through the middle. They wouldn't know the meaning or significance. It would just be a purely sensory thing. Gradually, as they grew, it would become a ring. They'd realise it was something people put on fingers. Lots of rings. Gradually, they would realise, especially according to the culture in which they were born, the significance of a wedding ring over other rings. You might then have a wedding ring of your own. And the associations and attitudes you have towards it gradually might evolve as we go from the honeymoon, let's say, through to the divorce, very cynically. So gradually, this object, this simple object, has a whole range of associations that will trigger according to your age, your culture, your own personal experiences, way above and beyond this gold shiny thing, right? So an object will have a significance. Now something like this, which hopefully is a grown-up dressed as a ghost, in case you don't know what this was, I hope everyone would see this straight away as a grown-up dressed up as a ghost. To a small child or someone with Alzheimer's, that would be very frightening, because they would lack the checks and balances of the adult mind. In Alzheimer's, as those connections are dismantled again. So you wouldn't understand, you wouldn't be able to see the meaning. It would simply be some frightening thing that you couldn't put into the checks and balances, into the context that is, for many of us, the blessing of the adult mind. So it gives a significance to things. And finally, as we start to make more associations, then things start to have a deeper meaning. Why am I showing you a candle? Well, it doesn't put me in a very good light, actually, but I think it's an illustrative story of my little brother, who was, as I told the ladies this afternoon, put me off ever having children, because he's 13 years younger than me, and I remember what it was like. And when he was 3 and I was 16, I went in for torture of my brother. Some of the torture was things like putting his water pistol in the oven and letting him see it melt, which I thought that was really good. It's plastic, because he was squirting at me, and there's a glass oven. This is what I mean by torture, and he still remembers this to the day. Another form of torture, which is why I'm telling the story, was I forced him to learn Shakespeare. I thought that was quite funny, having this 3-year-old learning it. Tomorrow and tomorrow and tomorrow creeps in this petty pace from day to day. And as someone said, that must have gone down a storm in playgroup, having this 3-year-old saying, anyway, so as you'll know, it carries on. Out, brief candle, life is but a poor player. Now, had you said to him, and this is my point, Graham, that being his name, what does it mean, out, brief candle? He might have said something like, well, you have a candle on a birthday cake and you blow it out. What he wouldn't have said, oh, it's a metaphor for death. And although he learnt with great speed those lines from Shakespeare, he didn't understand them. He couldn't understand the meaning, the real meaning of out, brief candle. That only comes with the checks and balances, with the associations, with the parallels, the context that having a mature framework, conceptual framework, can provide for you. So I'd like to suggest to you that the biological basis of the mind is not some airy-fairy alternative to the squalor of the physical brain. It is indeed the personalization of your brain through the unique dynamic configurations of your connection of neurons, driven in turn by your unique experiences, and that's why you're unique. And so slowly, this interaction with the world, here we are, this is downtown Oxford, some people think. I like this picture, that everyone is doing their own thing. Everyone is on their unique trajectory with a past, a present, and hopefully a future. Causally linked sequences that are not randomly accessed, but are there in a very specific linear space-time narrative. And as one thing leads to something, so you become the person that you are. I'm sure everyone in this room has passed an exam. You can't unpass that, it's part of you. It may be that you failed other exams, it may be you didn't make the most of whatever it was you'd been passing the exam in, it may be you changed your views on exams, but you passed an exam. No one can undo that. No one can undo that. That's part of you, and it led to various consequences or lack of consequences or different things, but it is part of you. That's something that happened. That's part of you that can't be reversed, and that's something else I want to turn to later. This irreversibility. It is therefore meaningful. It has a significance, because it's something, if I dropped a bit of paper on the floor and picked it up again, that would be meaningless. It would be reversible. This is not. This is something that's important. And slowly these things embed themselves in your brain connections, in this endless iteration with the outside world, so it's never the same for a moment. Okay, so that's the first thing. If you wake up now, second point, second conclusion, is if the environment is key, then it's important that we now contemplate the environment on the 21st century and how unprecedented it might be in changing the way we're going to think and feel. I didn't like this picture, look at it. That's what have we become? Okay, let's briefly gallop through the technologies. I wanted to do this broadly because I was aware that perhaps many of you may not be biomedical technologists, so I just left this one, nanotechnology here. And as you can see, it obviously plays to the fact that nanotechnology is engineering on the scale of a billionth of a metre. I often think that trying to savour the full implications on the material world of nanotechnology now would be like asking someone in a wattle and daub hut in the Middle Ages to contemplate what plastics were going to be and what they were going to do for us. I think it's going to be astonishing. I'm not a material scientist, so I'm not going to dwell on this, but we will see the physical world having very different properties than it does now, which may change our whole perceptions. More specifically for our talk, let's look at the biomedical applications. And this is from work by Peter Fromherz in Germany. You can see this amazing brain cells growing, nerve cells growing on an integrated circuit. Nerve cells are brilliant electronic components. They've had the whole of evolution to become so. They have brilliant capacitive properties. They operate by generating tiny voltages, and they work as carbon-based machines, if you like, or components with silicon very, very well. And as you can see on the next, you can actually have neurochips even now. So here you see a circuit, and then like there the triffids, that's a cell splodging down in the middle. And then if you look down on an array of them, you can see a rather primitive arrangement, but one nonetheless where they've all, with great exuberance, hooked up with each other, forming this neurochip, a hybrid type of computer, which I think is a very exciting technology. It doesn't mean to say anything to do with quantum computers, nothing to do with that at all, but it is everything to do with exploiting biological properties of tissue and carbon-based systems to harness that with electronics, which I think could be quite exciting, or challenge our notion of that division of carbon versus silicon, for example. And if you can put brains on chips, then can you put chips in the brains? And I wouldn't ask such a question if you couldn't. This is work of Miguel Nicolailis from Duke University, working with quadriplegic patients. And what he's been able to do, these people obviously who can't move from the neck down, what he's been able to do is analyze the electrophysiological signature that is generated, as we saw prior to a movement. You've seen that the important thing before a movement is the pattern of electricity that is generated, the changes that makes in the brain. And what he's done is feed that into a computer, which then next time round will recognize that signature and in accordance operate a prosthetic limb so that a quadriplegic person can now move. So that actually is quite exciting, but on the other hand it's slightly spooky that there's been an interception between thought and movement from the outside, but a great medical advance. This is taking it to the extreme. This is Ian Pearson, British Telecom, and his view of evolution and what's happening. Here we have the first 1.5 million years as we progress from Homo habilis, the tool-bearing ancestor, to when we stood up, Homo erectus. The Neanderthals didn't last very long, at least not literally. I think metaphorically there's some I can think of as Neanderthal. Anyway, and then we have Homo sapiens, of course us, and as you see rather gloomily here, I think some people think it's what I am, Homo sapiens ludditus, tapering out in favour of Homo machinus. I mean, that's a kind of joke. But on the other hand, if we progress to this notion of cyborg and increase interface with artifacts and artificial devices, it's something to think about, not least in the realms of an idea called transhumanism, which has been around for a long time, as you can see from this kind of picture. But here we are going more advanced to the governor of Los Angeles here, as was. But it's been described, this notion, California, is this notion that you can enhance perfectly good skills, physically and mentally, with either chemical or electronic devices. This notion that's been called transhumanism has been described by Foreign Policy magazine as one of the world's most dangerous ideas, and we don't have time for me to articulate all the ethical implications and the change in worldview if we have some people enhanced and others who aren't, nor does it answer the question why one would want to enhance oneself in this way. Again, we can discuss that if you wish. I just place it before you as something that needs to be thought about for the future. So, with nanotechnology then, we are merging the body with the outside world. We are challenging the firewall that previously demarcated your body from the outside world. Briefly, biotechnology. We all know that health is improving on the whole, and I'm happy to talk about dementia because that sadly needs a lot more attention than it is at the moment. But in pharmaceuticals, we're going from 400 to 4,000 drug targets. Pharmacogenomics, a jaw-breaking term, most of you are familiar, is exploiting the fact that we can look at the genetic profiles of individuals and instead of a one-size-fits-all therapy, actually give a bespoke medication whereby one can minimize side effects and target your weaknesses. Early screening, of course, will be possible with the genetic technologies, and a whole new type of medicine with stem cells, so-called regenerative medicine, is revolutionizing notions of treatment in many areas because you have these very obliging cells, stem cells, which will become whatever they're placed into. They'll adapt to any environment, whether it's bone cells or heart cells or even brain cells. There are certain caveats, but nonetheless it is an ethical issue, of course, but it is an exciting way forward. Whether we like it or not, The medical advances, the therapeutic advances, will go hand in hand with appearance. For example, here, I don't know if any gentlemen here are worried about them being follically challenged, but stem cells are being used now, as you can see. I don't know if this is what Wayne Rooney had, but anyway, so, as you can see, it can be adapted to what you look like. And I think there's good and bad here. I don't think we should be too high-handed and high-minded of dismissing the importance, especially for women, of the health impact of what you look like. There's a very good charity, Look Good, Feel Better, where the ladies there who are having chemo are given advice and help by the cosmetic industry on how to make the best of their changed appearance, and they really do well. They look good and feel better and get better than otherwise. So I think it's a very grey area between health and what you look like. On the other hand, we would have worries, I think, if techniques become so standardised and cheap that it becomes unusual to have ears that stick out or a large nose, and we are pressured into having standardised faces. I think that a bit like on the West Coast, where everyone feels they have to. That again would be sad and would questionably challenge our notions of identity. So again, it's a very complex issue, and I can't do justice to it in a few moments. A reproductive status, many people might object to this, and I'm not endorsing it, I'm just reporting it, that if you can not just freeze and thaw eggs for women and prolong their reproductive life, but eventually take genetic material from any cell of the body, combine it with anyone else's, then in theory, someone should don't mind having IVF, anyone of any age or sexual orientation could have a child with anyone else of any age or sexual orientation. The child would have potentially the two genetic donors, the donor of the egg and the donor of the womb, and others bringing it up, potentially 6 parents, but that's another issue. And I say these are things that we need to think about, because it's better to be on the front foot than the back foot, and I'm not saying this is what we want, but we need to think of the implications. We don't have to think too much into the future about work span. I'm sure that Cameron soon will latch onto this, grey power, where soon they'll be saying the pension age should be abolished altogether because it will stimulate your brain, and in a world where there's not a premium anymore on mobility or strength, why not have everyone working all the time? And it'll be good for the person in question. So let's think about what this will mean. I'd like to suggest to you that health, appearance, reproductive status and work span are normally how you allocate someone to one generation or another. In the extreme, imagine, as we've seen, that biotechnology is challenging all those 4 categories. This means that perhaps in the long run, in the long distance, I've written a novel about this actually, which is coming out next year, that you'd grow up, you'd look pretty much the same all your life, you'd be reproductively active pretty much all your life, you'd be healthy all your life, you'd work all your life, and then you'd die. So instead of the generations, you'd just have an adulthood. And you can see there's both. This gives you a funny feeling not to have that generational narrative. But nonetheless, what I'd like to suggest is that just as nanotechnology was challenging the firewall of the brain and body, so biotechnology might be challenging the generational divide, again a traditional boundary. What about information technology? And that's really something that's with us now. Look at this statistics, there's many. This one, in the States, between 13 and 17, over half the children are spending 30 plus hours a week in recreational use of screen technologies. And what concerns me there is not the 30 so much as the plus. This means at least, 4 or 5 hours a day after school, not giving someone a hug, not going for a walk, not feeling the sun on your face, not smelling the sea, not talking to someone face to face. It is a given in neuroscience that this will, given the plasticity of the brain, change the brain. The question is it good or bad? Now, I've been much misquoted on the web and in the blogosphere and so on as saying that this is all bad and computers are bad. I think that's about as absurd as saying a car is bad. But what I do say is that we need to think about this. We can't rather complacently think that we are inviolate, given the sensitivity of the brain to the environment. We have to explore the good and the bad, the opportunities and the threats that this poses. And both in the business world as well as your private lives, this will have a huge impact. To say it won't is not doing anyone a service. And we already have evidence, we'll see, that there are changes. Okay, just to show that I'm not this Luddite, this is a good book by Stephen Johnson, Everything Bad is Good for You, which, as its name suggests, promotes the power of screen technologies. And he says many things, for example, improved short-term memory, and perhaps seemingly very attractive, a raised IQ. There's been a raised IQ in many different societies. And one could argue that this is because when you engage with screen, especially computer games, you're rehearsing the kind of skills that you would rehearse in an IQ test. That's to say, you're using mental agility to see patterns, to get to a specific answer. in a fixed period of time. You're, in a sense, being like a computer yourself. You're looking for patterns, you're analysing, and you're getting to an answer. But as he himself says, just because we've seen an increase in IQ, we haven't seen an increase into the insight into the Middle East situation or to the economic crisis. And just because you can process information does not mean to say you have knowledge. They're not the same thing. And processing quickly and efficiently and giving good responses is not the same, I would contest, as understanding something. And that's not to say it's bad to process things quickly and be good at IQ tests, no, but there is more to us than that. We are more than just stimulus response machines. We are creatures that understand and think. There's a middle bit that goes on that is not being necessarily exploited. So, let's unpack now. These are the three areas I'd like to unpack. So this is the next point, if your mind has wandered. Let's look at social networking sites first, because I think these issues need to be nuanced and thought about a little bit separately. When you talk to someone, as I'm sure many of you, especially those who are in the business world, are aware, words only have 10% of impact. Eye contact and body language take a large impact on how, when you first meet someone, and we know that you can really freak someone out by staring them in the eye continuously. Unless, of course, you're in love with them, I suppose, then that's okay. You can stare each other in the eye. And you can equally freak someone out if you don't look them in the eye at all. So this degree of engagement of eye contact is something very sophisticated. It varies culturally, it varies on how well you know the person, the nature of the relationship, and so on. Body language, similarly, you can pick up on this even though you're not aware of interpreting body language and what it says. You don't have to speak a foreign language to know if someone is angry with you or if they're happy by the tone and the volume and the rate at which they're speaking. Again, a very important part of communication. Pheromones, that predisposition to whether you like someone or not, that is very poorly understood, but nonetheless, I think very relevant. Most important of all, physical contact, not been quantified. My dad died last February, and I'm sure you've had equally searing experiences of something like that, and we all know that, as I did then, if someone just put their arm around me, that was far more important and had much more impact than someone just saying, sorry, your dad died. Just saying, sorry, your dad died, was not exactly doing it, whereas someone put their arm around you, very, very powerful. But if you get that wrong, if you touch the wrong person in the wrong place at the wrong time, then obviously it's terrible. So eye contact, body language, voice tone, pheromones, and especially physical contact are all vital parts of interpersonal skills and developing empathy, and yet none are available on Facebook. So if you have a very impressionable young brain with the evolutionary mandate to adapt to an environment, and you are not able to rehearse these vital skills of eye contact and body language, how are you going to learn those things? When are you going to learn those things? And if you don't learn those things as well as people from previous generations who weren't stuck with 900 friends they had to talk to, it's going to be aversive and unpleasant to do. And if something's aversive and unpleasant, you try and avoid it. So I often think this is a bit like meat eating. You know, we all would take our sanitized plastic-wrapped lamb chops off the shelf. Far fewer people, I'm a physiologist, I wouldn't mind, but far fewer people would kill an animal and butcher it and skin it. Skinning animal, real-time conversation, in real life, looking someone in the eye, touching someone, You know, and there might well be that kind of similarity. Now, this is a trend, and I've been misquoted as saying things cause things, but I think, just like with smoking and cancer in the 50s, once we start to see trends, we should start to question those trends and see if the correlations could be in a way causal linked. And this is a recent study from the University of Michigan showing indeed there has been a decline in empathy over the last 30 years in 1,400 college students, particularly marked in the last 10, coincidental with the rise of the so-called digital native. Another issue is people with autistic spectrum disorder are particularly comfortable, as shown here, in Second Life, in cyber activities. And I'd like to suggest that that is because it's not putting a premium, as in real life, on eye contact, body language, hugging someone. So therefore, the playing field is more levelled. I have not ever said, incidentally, despite being quoted, that this causes autism. Again, it's with the relish that the press have to sensationalise a story. So what does that mean with empathy then, and identity? Because if you're incessantly connected and incessantly networking, incessantly in the moment, where do you end and someone else begin? If you're constantly at the screen, what have you done? If that's your identity, who are you? Where's all the things that can't be reversed? What does that say about you? And if you look at, I love this history of blogging, I think it is very telling. 1999, I just have to tell someone about this thing my cat did today. 2004, oh my God, cat pictures. Okay, YouTube. 2005, moving cat pictures. Then that pinnacle of civilization, Twitter. 2007, 1 p.m. my cat just sneezed. 102, cat sneezed again. 104, cat hasn't sneezed recently. Getting worried. Yeah? Doesn't this remind you of some kind of people that need incessant feedback about banal aspects of their life and assume that other people are interested in it and spend their time reading about other people's and commenting? Does it remind you a little bit like, look at me, mummy, I'm putting on one sock. Look at me, I'm putting on another sock. Because if you don't look at me, how do you know I exist? How do I know I exist if I'm not constantly reassured all the time from other people? So I'd like to suggest that there's reduced empathy and less robust identity as a result, possibly, of social networking. Possibly. I would like to see more epidemiology, more exploration of this. And I had this idea for a brilliant TV series. Why not take some digital natives who are obsessionally using the screen and put them in something like the Big Brother house equivalent without any screen technologies and see what happens afterwards. I thought it would be a very good reality TV program. Okay, and round to the screen, gaming. These two little boys are not playing with each other. They're playing with the screen. And we know that the screen has to do something very special, because why else should a two-dimensional screen that only accesses hearing and vision outcompete, as by definition it does, outcompete a three-dimensional world with five senses? It must be doing something very powerful that the real world with five senses and three dimensions is not doing. And I'd suggest that it's because it's supranormal, super bright, super fast, super interactive, that draws the attention to it but then fragments it as you hypertext and look around and respond, following your evolutionary heritage of becoming a computer because you're adapting to that environment. Now we know, again a trend, and possibly related to this, I say possibly, I think it should be explored, that there has been an increase in prescriptions over the last 15 or 20 years for methylphenidate. You may not recognise that name, but if I say that's the generic name for Ritalin for attentional disorders, then you can see that there are grounds for thinking that perhaps there might be a link. Yes, I know that it may be that methylphenidate is being more liberally prescribed. It might be that it's being medicalised as a condition. It wasn't 15 years ago. But not mutually exclusive to that might just be the possibility that if you take a young brain that has, as I say, its evolutionary mandate to adapt to an environment, that environment is a fast-paced one of incessant interaction. When they're then asked to sit still for longer periods of time, then they might fidget a bit because they haven't adapted to that type of environment, and then they'll be diagnosed with a so-called attentional disorder and given this very powerful drug, which is like giving someone amphetamine. So I just think we need to be cautious and explore that more than it is doing at the moment. Effects of gaming, then, I'd like to suggest is fragmented attention and shorter attention span. And finally, increased recklessness. Now, you in the business world are very interested in risk management, as are we all. Obama said that the financial crisis of a year or two ago was due to greed and recklessness. Let's think about greed and recklessness, especially risk-taking. If you ask a neuroscientist to talk about risk-taking, then we will look at neurological profiles of people that take excessive risks, the prototype of which was someone called Phineas Gage, the foreman on a railway gang, who one day was pushing with a tamping iron, pushing explosive down a hole. It went off prematurely, driving the tamping iron through his frontal part of his brain. I'm about to show you a picture of him, so if you're squeamish, and because now we are quite near dinner, close your eyes and your neighbour will nudge you when the picture comes off. Those of you who are brave enough to get your eyes open, you'll see the damage is really extensive. The point of the story was that it didn't kill him. And indeed, he could see and walk and talk just fine, despite the fact he had a big hole through his head. And he actually went back to work, and it was only as the weeks became months that people noticed a difference, which wasn't anything specific in his movements or his language. It was more in his character, becoming a certain syndrome called frontal syndrome, later repeated and seen with shrapnel wounds when people had head injuries. But this syndrome encompasses taking excessive risks. Not good if you work with explosives. And in fact, he left because he became so impatient and unpleasant to work with, so irascible and childlike. He became a fairground freak where he showed off his wound and actually became an alcoholic and died of alcohol poisoning. That was his life. Anyway, the area damaged was this area called the prefrontal cortex, which is a very interesting area for neuroscientists because compared to chimps, even compared to chimps, our nearest relatives, it's exaggerated in humans. 33% of our brain, only 17% in the chimp brain, 3% if you have a cat in cats. What does it do? Well, we know many things. It's like a kind of kitchen sink for neuroscience, lots of ideas. But we do know if it's damaged repeatedly, you get recklessness. Now, there's other ways in which we can see an under-functioning prefrontal cortex. Let's get some water. You can see here people who have a high body mass index, that's to say who are heavy, compared to their height, they have an under-functioning prefrontal cortex. What do we know about people who are obese? And we know that is something that is on the increase in our current times. We know that they take greater risks. So there's a link between people who are obese, under-functioning prefrontal cortex, and taking risks in gambling tasks under experimental conditions. Another group of people are schizophrenic people. As you can see here on the left is control, on the right one with schizophrenia. And finally, we think about schizophrenia as some dual personality. It's not that. It's a complex malfunction that has much in common, funnily enough, with childhood. The particular similarities are that both children and schizophrenics are easily distracted. They both have a short attention span compared to adults. They have an inability to interpret proverbs. So rather like my brother didn't really or couldn't understand out, brief candle, if you ask a schizophrenic, what does it mean people who live in glass houses mustn't throw stones? They'll say something like, or if your house is made of glass and I throw a stone, your house will break. So again, they can't see one thing in terms of other things, and in both cases, there's an under-functioning prefrontal cortex. The prefrontal cortex is only fully mature in late teenage years, early 20s. This was highlighted recently in a Royal Society report in terms of changing the rules for criminality and when you are responsible for your actions. They were worried about adolescent behaviour if the prefrontal cortex was still developing as it is. You may have heard that on the news. So what do children and people that eat a lot have in common with people that gamble a lot? Well, let's think about that. Anyone who eats knows the consequence of eating, but for obese people, the thrill of the food, the taste of the food trumps the consequences. Anyone who gambles knows the consequences of gambling, eventually, but the thrill of the roulette wheel, the horse past the finishing post, that excitement in compulsive gamblers trumps the possible consequences. How does that compare with schizophrenia? Well, let's look at the hint here provided by this very famous series of paintings where top left you see in the early stages of the disease something that clearly is a cat. By the time you get to bottom right, there's been a deterioration in the disease, or perhaps not artistically, you might think it's better, but in psychiatric terms, the person has deteriorated, and you can see it's no longer recognizable as a cat. The clue, I think, is that we've gone from cognitive to sensory, backwards in time. So could it be that with people with underfunctioning prefrontal cortex, that what's happening is the thrill of the moment is trumping the consequence, whether it's food or the roulette wheel, or having an excessive amount, in the case of schizophrenia, of dopamine. All these things are leading to an underfunctioning, or tied in or correlated with an underfunctioning prefrontal cortex. Tied in with that then, if we look at video games, this is recent in the Telegraph, I've highlighted it, was a recent study, and this again I like to produce when people say there is no evidence. What is this if this is not evidence? It's in a peer-reviewed journal with brain scans showing, I hope you can see the yellow blob there, an enlarged area of the brain that is more significant in people with video games. Again, we don't know it's a correlation or a cause, you never do with the brain. But my suspicion is that given it's adapted to the environment, this may well be a consequence. And this is an area of the brain that releases a chemical called dopamine that is related to addiction and reward, and indeed arousal. So when I said this to a journalist a year or so ago, I said, do we really want a world? Are we inducing a world where people sit in front of a screen saying yuck and wow and yuck and wow? Because I talk fast, they thought I said yucca wow. And what happened as a result of that was it started a craze, and there were 75,000 hits on Google in 24 hours, and that spawned in turn products. Some nerd had already taken the domain name, First Church of Yucca-Wow, there we are, breezy people, world of no consequences, and t-shirts and mugs with Yucca-Wow on. The reason I mention this, apart from showing the power of viral marketing, is clearly that this appeals to people, this notion of no consequences. What you see is what you get, you're in the moment, Yucca-Wow. Now, what do we know about this? Well, of course, since time immemorial, people have liked to live in the moment. Since the ancient Greeks, this is Euripides' Bacchae, where the king who tried to repress the Dionysian worshippers, these crazed women high on wine, they tore them apart. We talk about having a sensational time. We don't say, if I said, no, let's go and have a cognitive time now, who would come with me? No one. That's what you're having now, sensational time. Yeah, you're having your raw senses. You let yourself go. the very word ecstasy in Greek is to stand outside of yourself. You can do this in many ways. You don't have to tear kings apart. You can actually go whitewater rafting, or here from northern Queensland when I was there. Note here, the selling point of this hovercraft fundraise was to be out of control. Interesting, pay money to be out of control. You let yourself go, you're abandoned. And I think this has gone on since we stalked the planet. My concern is that we're doing it in a more exaggerated way. So arousal, addiction, and rewards, all of which can unfold from playing computer games, are all rated as this chemical dopamine in the brain. It's not the chemical for that, but it plays an important part in it. And it's like a fountain in the brain. And guess what? It inhibits the prefrontal cortex. So we can think of a cycle of intense stimulation of the screen with gaming, making you very excited because it's very fast and interactive, causing therefore high dopamine release, which underlies reward-seeking addictive behaviours. More dopamine is released, which inhibits prefrontal cortex, thereby bringing about conditions similar to childhood schizophrenia or obesity, where there's a drive of sensation over cognition, therefore increasing the appeal of the screen environment, which offers you those things, and would have a cycle. And that's just a suggestion of what may be happening. To show again that there's changes, this is another peer-reviewed paper that came out last year showing indeed there was a high correlation between people who are obsessionally gaming and abnormalities in brain scans. So I don't have a picture of that. Finally, search engines and what that might mean. We talked about not the ability to interpret proverbs and so on. What about abstract words like honour? If you Google on honour, this is what you get. Now, if you showed that to a Martian, would they understand what honour was? How would you show honour? How would you show out brief candle? You wouldn't be able to show those things. So what I worry about is the lack of metaphor and indeed abstract concepts and how those are conveyed, because those enrich our thinking. This notion of fast processing, which we've talked about, versus true understanding and meaning. And just to show I'm not alone, he's now the chairman of Google, not the CEO anymore, but Eric Schmidt. I worry that the level of interrupt, the sort of overwhelming rapidity of information, is in fact affecting cognition. It's affecting deeper thinking. I still believe that sitting down and reading a book is the best way to really learn something. I worry that we're losing that. Now, surely we should heed these kinds of thoughts from someone who heads up Google now. I think it's really important. For example, if you play a game to rescue the princess, in this case the noble Princess Yukihime, do you really care about her? Does she mean anything to you? I bet you don't care about her at all. Whereas when you read a book, you do care about the princess. Why? Because she has a past, a present, and a future, the narrative, just like you. She has relationships just like you. She therefore has a significance, a meaning, as I've said before, just like you, in a way that an isolated icon doesn't have. So let's think about how we can promote creativity. Well, here are people living for the moment. This is us in a half an hour's time, possibly, after having a sensational time. These people are not self-conscious. They've let themselves go. They're in a world stripped of all cognitive content, techno, whatever it is, techno, where you are paying money to be in an environment of wine, women and song, drugs and sex and rock and roll. All these things in their different ways are giving you an abrogation of the sense of self. You are just the passive recipient, once again, of raw senses coming in. The beat of the music, the pulsating lights, let's hope not too much smell or touch, but nonetheless, all those things are not having a cognitive content, a meaning. I don't think these people are worried about the mortgage or anything. They're there in the moment. They're living for the moment. That's what we talk about, living for the moment. Whilst thinking is a very different thing. So let's look at the two differences of prefrontal underfunction and functioning. Strong feelings versus thinking, sensory versus cognitive, here and now versus a past, a present, and a future. Do you remember I said about passing your exam? The external environment driving each moment, as opposed to internal perceptions doing it. Little significance. What you see is what you get. A candle is something you blow out on a cake. It's not a metaphor. Whereas here you can have a personalised meaning. Here there is a reduced sense of self. You've let yourself go. Here this is your identity, your continuity. Here there is no time and space. Here there is a clear set of episodes that are sequentially linked. This is mainly children. This is mainly older people. This would be more dopamine, this less dopamine. It was ever thus. It was ever thus. The difference is that if we're now creating an environment that predisposes people to stay on the left, then this might be the consequence. And that's what I'm going to talk to the gaming industry in about a week's time, actually. They already are trying to reassure me that it's not addictive, and they're getting very nervous, a bit like the tobacco companies in the 50s, because they know soon they're going to have to put health warnings on and stronger guidelines on. So they're very much wanting to be seen as being responsible, which I think is very interesting. So you can see here that I think there is some issue here. Now let's get to creativity in that world that we've just looked at. If you think about what it takes to be creative, children are often creative, schizophrenic art and poetry, drugs, people claim they're creative when they take drugs, all of which can be interpreted as a breaking of connections. Children are just growing them, schizophrenics they're impaired, and with drugs you're impairing them with chemicals. And all these things, people can say, well, look, I'm very creative, but I don't think they are, because as you can see, they don't guarantee you're going to be creative, nor do they mandate it. You don't have to be a child or a schizophrenic or a drug taker to be creative. So although there may be something here linking, it's the first step. What they've done here is to look at a disconnect, to challenge dogma. The man who built the Mini, I'm sure you know, challenged dogma. Why should the engine be in the front of the car? Back of the car. In science, you challenge dogma all the time. There was an Australian physician who won the Nobel Prize eventually for challenging the dogma that ulcers were caused by stress. He showed it was a virus. So very exciting differences. So premium on deconstructing or to abstract sensations, then bringing together unusual sensations, but still that's not quite there. If we look at this painting by Phoebe Collins, who painted this aged 4 years old, she's the daughter of one of my postdocs, she's done those two things. She's brought together unusual elements, she's defied dogma. You don't normally see sheep with purple faces and magenta bodies, but this is not a work of art. This isn't going to hang in an art gallery any day soon, whereas this sheep does. So what's the difference between the two sheep? Why is her sheep acclaimed, whether you like it or not, is recognised as art, as something creative, whereas Phoebe's sheep sadly not? What is the difference? They've both challenged dogma, they've both got unusual sheep here, one in formalin. So what's the difference? Well, I'd like to suggest that the crucial issue, the big difference, the thing that we've got to try and aim for, is that Phoebe's sheep does not make you see the world in a new way, whereas her sheep does. You see a new connection, it has a new meaning. You may not like it, but you see the world differently. And these new associations give you a new sense of significance, but you must have the associations there. So what I'd like to suggest is that you have to give something a meaning. So how does something have a meaning? Well, we've looked at neuronal connectivity, we looked at the candle, and we've seen that you can, of course, make associations through your brain cell connections. And this particular one, which is very abstracted, we will have our own kind of little associations of different connections derived from our own individual experiences, if you like, over space. But we can also have temporal connections. Something has significance because it's called something else. And I think that's what thinking is. And now, remember the quote, thinking is movement confined to the brain. I remember to mention it. A movement is a sequence of steps. You don't just do them in random order. One step leads to the next step, leads to the next step, leads to the next step. A sentence is a sequence ordered of words. It has a beginning, a middle, and an end. Chapters in a book have a clear beginning, middle, and an end. A book has a beginning, a middle, and an end. Thinking has a beginning, middle, and an end. That's what thinking is, whether it's, here we are, logical argument, 2 equals 1, whether it's a business plan, I put this in for business folk, whether it's a story. They all have stories. They're all beginning, middle, and end, unlike a feeling, which is just in the moment. And this is what I've mentioned. This is a shameless plug for my 2 most recent books, ID, and one that was out just about a month ago, You and Me, available on Amazon in both cases, whatever it is. And we know that stories have an appeal. Once upon a time, how exciting is that? Your life story, beginning, a middle, and an end, a sequence that's linked where there is a significance because it can't be undone. Unlike a computer game, someone can't be undead. It's something that has a very big meaning. So I think stories are essential for creative insight, to give you meaning, and thinking gives you temporal sequences. You need temporal sequences, and this identity is a combination of those things. And without identity, without meaning, who are you and what are you? All of us are after meaning or significance in our lives. And to do things that are meaningless continuously, I think we do at our peril. So I'd like to suggest the mind of the future is both good and bad. Higher IQ, shorter attention span, improved short-term memory, icons versus ideas, a sensory emphasis, less empathy, less literate, less risk-averse, and less sense of identity. And this could be good and bad. I mean, it might be good to be less risk-averse, but you have to manage that. So how do we deal with that with goods and services for business? Well, I think it is analogous to climate change. I call this mind change. In both cases, this is unprecedented. In both cases, it's controversial. In both cases, we have a variety of issues we need to unpack separately, whether it's carbon sequestration and water shortages and energy. So we have search engines, and gaming and risk-taking, and we have empathy and social networking. All these things need to be dealt with separately, and they're not good or bad. It's like saying, is a car good or bad, as I said. The only difference between climate change and mind change, though, very important difference, climate change, as I understand it, is damage limitation. Mind change doesn't have to be that. And the reason I'm showing both problems as shown in our hands is that the issue is in our hands. And as I said at the beginning, when I said what the green was going to be, the future is in our hands to create an environment for our impressionable brains, our very vulnerable brains, to really for the first time bring out our true human potential. For the first time ever, we're going to live longer and healthier lives. We have more leisure time than ever before. What are we going to do with our time? What are we going to do for the second 50 years of life? What are you going to do if you're healthy and fit? You're going to play games all the time? What are we going to do? And I think we need to think of ways, and I speak to the business community, in which we can enable people to be creative and therefore as individual as possible. And the implications of this, I think we need innovative software, and I have some possible ideas on how to bring about some of those things. We need goods and services in the real world for enhancing the creative process, and we need a new type of consumer, we're getting a new type of consumer, and a new type of workforce. And I think therefore that this issue, as I said, is something that affects us on many levels. It affects us as employers, it affects us as consumers, it affects us as members of society, but above all it does affect us not just as parents but ourselves as individuals. Thank you.